Hi, Jamie. I think I could, give it a shot for this particular problem, but there are some things that you need to know. Like you need to know asymptotes and intercepts and rational functions. You got to know that, or this video is not going to make any sense to you. So you have to have covered that already to get to this question, because this is a major question that tests all the stuff of a rational function. So it says that this graph has vertical asymptotes at x equal -1 and x equal -5. Now, what that means very specifically is this. If you have a vertical asymptote, which I'm a math teacher, nobody wants to write vertical asymptote, I'm going to write VA for vertical asymptote. The vertical asymptote in a rational function lives on the bottom, right down here. And they told us in this problem that the vertical asymptotes are x equal -1 and x equal -5. So since my vertical asymptotes are x equal -1 and x equal -5, I can turn those into equations. And the way that I turn those into equations is just this. Move the number back over to the other side. All right? Because you get this by setting the equation equal to 0. So if I move the number back over to the other side, I've got x plus 1 equals 0. And I've got x plus 5 equals 0. These two binomials are my denominator. These are the numbers that are on the bottom. So for my rational function down here on the bottom, I've got, let me erase this little arrow here, because I just wanted to show you where the vertical functions lived, the vertical asymptotes. They live on the bottom. So those two little binomials go down there. So that's x plus 1 and x plus 5. If you set each one of these equal to 0, you get your vertical asymptotes of -1 and -5. Hope that's clear. Now let's move on. We've got a horizontal asymptote at y equals 0. Now that specifically means that, well, on the bottom, if I multiply this through, I'll have x squared, which means on the top, I either need to have an x or I don't need to have anything. Because when your horizontal asymptote is 0, it means that as you plug in numbers for x, as the bottom gets bigger, the top gets smaller, and well, I don't know if you noticed, but if I have like 10 divided by 10 million, it's going to be very, very close to 0. And that's what the horizontal asymptote tells you. It tells you in the long run, this graph is going to be hugging the x-axis. It's going to be 0. So our horizontal asymptote at y equals 0 is important, but I'm going to leave that to the side right now because I don't know if I have just a number like 1 on the top or if I have something like x minus another number on the top. But this next sentence tells me that my graph has an x-intercept at -4, and that's important. See, the x-intercept is at -4. So that tells me exactly what my top has to be. The x-intercept, let me tell you where it lives. The x-intercept lives on the top. And since they told me that my x-intercept is equal to -4, I hope you know in any graph what the x-intercept is. It is the place where the graph touches the x-axis. So that means when y is 0, x is -4. So if x is equal to -4, that means, let me move that x over there, that -4 over there with the x, then I'm going to have x plus 4 on the top. So far, so good. It's looking good to me. I like the way this is looking. Could there be a number out in front here? There could. So let's see what else they told us. They told us that it passes through the point 2, 2. And that's all we need to know. So if it's passing through that point, that means that this is going to be equal to y. And since I don't know whether or not I have a coefficient out in front here, I'm just going to put an a there. Because I could have a -1, I could have a 2, I could have a 3. But the fact that they told me that it passes through the point 2, 2, that means that I can plug that value in. So I'm going to come down here and write that it passes through that point. Now I want you to notice I haven't referenced the graph at any time. I don't need to, because I know that where these things live in an equation, and I want you to know where they live too. Because once you know where the vertical asymptote can be found in any rational expression, you'll be able to find it immediately. Once you know where the x-intercept can be found, you'll be able to find it immediately. And those two are the main things that build the equation. Did you notice that? Now, why is the horizontal asymptote equal to 0? Well, let me show you with this breakdown before we pass through the point 2, comma 2. All right, so if I go ahead and multiply this bad boy through, and I forget this little a just for a second, we'll scroll it down a bit. So I've got x plus 4, and on the bottom, x plus 1 times x plus 5 becomes x squared plus 6x plus 5. In order to determine what your horizontal asymptote is, you find the term with the highest degree, and in that case is x squared, and we're going to divide each term by the x squared. So that's going to give us x over x squared plus 4 over x squared, forgive my handwriting, over x squared divided by x squared plus 6x over x squared plus 5 over x squared. Now, let's see if we can simplify any of these. The only one that I can simplify is the x squared over the x squared. It becomes a 1. But all the other terms go to 0 because I can't simplify them. I got these fractional terms, and as I put in 1,000 over 1,000 squared or 1,000,000 over 1,000,000 squared, each of these numbers is getting closer and closer to 0. So just send them all to 0. So 0 plus 0 is 0, and 1 plus 0 plus 0 is 1. 0 divided by 1 is 0. That is the physical way that we find the horizontal asymptote. The way that I like to tell my students is this. Look at the degree on the bottom. The degree on the bottom is a 2. The degree on the top is a 1. When the degree of the numerator is smaller than the degree of the denominator, your horizontal asymptote is 0. Period. You don't have to divide by anything. So either way, let that be your guide. Anyhow, let's talk about this passes through 2, comma 2. So anywhere I see an x, I'm going to put a 2. And anywhere I see a y, I'm going to put a 2. So 2 equals, I don't know if I've got an a or not. We're going to find out together. And then we're going to plug in 2's everywhere there's an x. And we're going to leave all the other numbers, where they are. So I'm going to leave them the color that they are. Leave them black. So plus 4, plus 1, and plus 5. And notice these numbers are, being added. So go ahead on and add them and do what you're supposed to do with them. So come straight down here. 2 equals a times 6 over 3 times 7. All right. Now 2 equals 6a over 21. How do we solve this problem? We're going to multiply both sides by 21. 21 times 2 is 42. 42 equals 6a, which means a has to be 7. A could be a fraction. A could be any real number. Doesn't matter. In this case, it happens to be 7. So our final equation is y equals 7 times x plus 4 over x plus 1 times x plus 5. I hope that helps. If it doesn't, we can choose to get together tomorrow because that's when I do have office hours. But today I'm done at 1:30, so sorry about that.